Good morning, sir. My name is Rosshelle Alvarez, and I would like to discuss my report about Graphics Processing Unit. Every PC enthusiast knows that the Graphics Processing Unit, or GPU, is one of the most important components in PC architecture today. The more savvy among us might be well informed about the role a GPU plays in gaming as well as general computing. Before we proceed to the things that we should know about GPUs, let us go first to the brief history of graphics processing units. Back in 1999, NVIDIA popularized the term GPU as an acronym for Graphics Processing Unit. Although the term had been used for at least a decade prior to marketing the GeForce 256, however, the GPU was actually invented years before NVIDIA launched their proprietary NV1 and later the video card to rule them all. Here are the things to know about GPUs. What does GPU stands for? Graphics Processing Unit, a specialized processor originally designed to accelerate graphics rendering. GPUs can process many pieces of data simultaneously, making them useful to machine learning, video editing, and gaming applications. GPUs may be integrated into the computer's CPU or offered as a discrete hardware unit. What does a GPU do? The Graphics Processing Unit, or GPU, has become one of the most important types of computing technology, both for personal and business computing. Designed for parallel processing, the GPU is used in a wide range of applications, including graphics and video rendering. Although they are best known for their capabilities in gaming, GPUs are becoming more popular for use in creative production and artificial intelligence, or AI. GPUs were originally designed to accelerate the rendering of 3D graphics. Over time, they became more flexible and programmable, enhancing their capabilities. These allowed graphics programmers to create more interesting visual effects and realistic scenes with advanced lighting and shadowing techniques. Other developers also began to tap the power of GPUs to dramatically accelerate additional workloads in high-performance computing, or HPC, deep learning, and more. GPU and CPU working together. The GPU evolved as a complement to its cousin, the CPU, or Central Processing Unit, while CPUs have continued to deliver performance increases through architectural innovations, faster clock speeds, and the addition of cores. GPUs are specifically designed to accelerate computer graphics workloads. When shopping for a system, it can be helpful to know the role of the CPU and GPU so you can make the most of both. GPU versus graphics card. What's the difference? While the terms GPU and graphics card or video card are often used interchangeably, there is a subtle distinction between these terms. Much like a motherboard contains a CPU, a graphics card refers to an add-in board that incorporates this GPU. This board also includes the raft of components required to both allow the GPU to function and connect to the rest of the system. GPUs come in two basic types: integrated and discrete. An integrated GPU does come into its own separate card at all and is instead embedded alongside the CPU. A discrete GPU is a distinct chip that is mounted on its own circuit board and is typically attached to a PCI Express slot. Integrated Processing Unit. Integrated Graphics Processing Unit. The majority of GPUs on the market are actually integrated graphics. A CPU that comes with a fully integrated GPU on its motherboard allows for thinner and lighter systems, reduced power consumption, and lower system costs. Intel graphics technology, which includes Intel Iris X graphics at the forefront of integrated graphics technology. With Intel, graphics users can experience immersive graphics in systems that run cooler and deliver long battery life. Discrete graphics processing unit. Many computing applications can run with integrated GPUs. However, for more resource-intensive applications with extensive performance demands, a discrete GPU, or sometimes called a dedicated graphics card, is better suited to the job. These GPUs add processing power at the cost of additional energy consumption and heat creation. Discrete GPUs generally require dedicated cooling for maximum performance. Here is the infographics about GPU. GPU versus CPU. GPU has a better throughput. Group of thread executes the instructions. GPU works excellently for complex image processing tasks. Implements genuine thread rotation. Has fine-grained parallelism. The number of registers available in GPU can be changed dynamically. Better clock speed. In CPU, each thread executes the instructions individually. GPU performance is over 10 times faster than that of a CPU. Implements out-of-order execution. Has coarse-grained parallelism. Memory is available across all the multiprocessors or cores. And now let's go to the areas of application. What are GPUs used for? 2 decades ago, GPUs were used primarily to accelerate real-time 3D graphics applications such as games. However, as the 21st century began, computer scientists realized that GPUs had the potential to solve some of the world's most difficult computing problems. This realization gave rise to the general-purpose GPU era. Now, graphics technology is applied more extensively to an increasingly wide set of problems. Today's GPUs are more programmable than ever before, affording them the flexibility to accelerate a broad range of applications that go well beyond traditional graphics rendering. GPUs for gaming. Video games have become more computationally intensive, with hyper-realistic graphics and vast, complicated in-game worlds. With advanced display technologies such as 4K screens and high refresh rates, along with the rise of virtual reality gaming, demands on graphics processing are growing fast. GPUs are capable of rendering graphics in both 2D and 3D. With better graphics performance, games can be played at higher resolution, at faster frame rates, or both. GPUs for video editing and content creation. For years, video editors, graphic designers, and other creative professionals have struggled with long rendering times that tied up computing resources and stifled creative flow. Now, the parallel processing offered by GPUs along with built-in AI capabilities and advanced acceleration makes it faster and easier to render video and graphics in higher definition formats. Uniting fluid gaming experiences with the latest in visual technologies, Intel Arc graphics for desktops enables captivating content immersion. Intel Arc graphics cards include built-in machine learning, graphics acceleration, and ray tracing, hardware with scalable performance options for laptops, desktops, and professional workstations. GPU for machine learning. Some of the most exciting applications for GPU technology involve AI and machine learning. Because GPUs incorporate an extraordinary amount of computational capability, they can deliver incredible acceleration in workloads that take advantage of the highly parallel nature of GPUs, such as image recognition. Many of today's deep learning technologies rely on GPUs working with the CPUs. That's all for today. Thank you and God bless.